In the previous topic, we looked at the beneficiation process to separate coal from its gangue. Some of the principles we discussed in the previous topic are applicable to the separation of metalliferous ores from their gangue, but some of them are different. In this topic, we'll see what the differences are. A fundamental difference between coal and metalliferous ores is the fact that coal, when it's mined, separates relatively readily from its gangue materials or its mineral materials, whereas metalliferous ores tend to be intimately associated and must be ground to a very fine powder in order to make them separate. That means that the density separation methods we talked about in the beneficiation of coal don't work as effectively when the particles are very small, because even though density can be used as a separation principle, the rates of settling of very fine particles are so slow that the processes become uneconomical. Instead, we need to use more efficient processes, and the one that's commonly adopted is a process called flotation. Flotation utilises the fact that the metalliferous ore particles and the gangue minerals have different interactions with water. Fundamentally, flotation relies on the fact that hydrophobic ore particles and hydrophilic gangue particles can be separated. Hydrophobic means water-fearing, and hydrophobic substances fundamentally repel water. Hydrophilic means water-loving, and these are attracted to water. In flotation, we create bubbles as a froth that sits on the top of a suspension of crushed ore. The hydrophobic ore particles, which don't like to stay in the suspension, preferentially petition to the surface of the bubbles, while the gangue minerals, which are happy to stay as a suspension, stay in the water below the froth and sink to the bottom. If the froth is continually replenished, then the ore particles float to the surface in the froth, which can be skimmed off and the ore particles recovered. To enhance the formation of a froth, we add chemicals called frothers, which are surfactants like detergents, which help to create small bubbles and a stable layer of froth at the surface. There are four basic types of flotation cells: mechanical, column, Jamison, and reflux flotation cells, and there are many variations on these basic themes. We'll have a look at the simplest of these, the mechanical flotation cell. Mechanical flotation cells consist of a stirred tank. Air is sucked in via a central motor shaft, and the spinning impeller acts to break the gas into fine bubbles, as well as to keep the solid particles suspended. The bubbles rise to the surface, forming a froth layer, hopefully carrying the hydrophobic ore particles with them. This froth overflows and is collected as the concentrate. Water is also withdrawn from the base of the cell to remove the uncollected solids in a tailings stream. We can wash the entrained gangue mineral from the froth layer by adding wash water. Coal is somewhat naturally hydrophobic, and so it can be readily floated. However, most mineral ores are naturally hydrophilic. What makes flotation such a powerful tool for mineral processing is that we have learned how to selectively modify the surface properties of different ore minerals to make them hydrophobic. We use various types of chemicals, remembering that we've already spoken about frothers, but there are also collectors, activators, and depressants to control the particle surface properties. A collector makes the surface of a particle hydrophobic. An activator makes a particle surface more responsive to the collector. A depressant makes the surface of unwanted particles less responsive to the collector. We can also add acids or bases as pH modifiers to control the responses of minerals to the collector. Flotation has the capacity to recover different mineral species at different stages in the process. In this way, we can beneficiate complex mixtures of ores to produce a range of different mineral products. To illustrate the power of the flotation process, consider this sample of low-grade copper ore. If this copper ore is crushed to produce a feed stream for a flotation process, we end up with a powder that looks like this. After flotation, we produce a stream of tailings that looks like this, and a stream of recovered ore that looks like this. Flotation is a powerful tool to recover small amounts of valuable minerals from low-grade ores. So having generated our product, the next task is to get it to the customer. We'll take a look at how this is done in the next topic.